Assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. I want to first start off this episode by saying, may the 4th be with you all. Since yes, today is Star Wars Day, at least as the day this episode is coming out, it is currently May 4th, so in honor of Star Wars Day, may the 4th be with you. And with that, let's get into how we start off our episodes with our trivia question. So this week's trivia question is Ansible, which is an IT automation tool, is primarily written in what programming language? So what programming language is Ansible primarily written in? And that is your trivia question for the week. So before we get into our cybersecurity tip, one thing I wanted to quickly touch on is we talked not too long ago about how I kind of went down the rabbit hole of diving into MS-DOS and writing some code for it and kind of going through that whole process. We did a few episodes on it a few weeks ago, but Microsoft recently on their MS-DOS GitHub repo actually published the source code for MS-DOS 4.0. So the version of MS-DOS that I was mainly writing code for was 6.2.2 or 6.22, 22, whatever it was, 6.22. So a little bit newer, but it is still cool to see that code is up there. There's a makefile there. I'm not sure if anyone's tried to build it from source yet. I personally haven't, since I kind of just discovered it before recording today. So I haven't tried that out. But in theory, you could build your own version of MS-DOS 4.0 from source if you so chose to. So that is cool to see. It's under the MIT license, so it's basically you can kind of do whatever you want with it, more or less. Of course, you still kind of have to reference and include the original license and all that good stuff. I'm not a lawyer, but the MIT license, from my understanding anyway, is very, very lenient on what it allows you to do. So yeah, just thought I would bring that up. And with that, let's get into this week's cybersecurity tip. Now, when it comes to cybersecurity, one of the most important things is account security, and the ways that you can do that is through things like multi-factor authentication, or more commonly known as two-factor authentication. And that is a pretty lame cybersecurity tip, if I'm being quite honest with you, because it's kind of one of those that everyone should know at this point. But the reason why I bring it up is I believe we talked about this in January, but if we didn't, forgive me. But I believe in January we talked about this critical vulnerability that happened with GitLab, where attackers would be able to send password reset requests to unverified emails. And basically what this means in layman's terms is they could send a password reset for your account to their email address. So that's obviously not ideal and not what you want to have happen. It's been since patched in newer versions of GitLab. But the reason why I'm circling back to this is on May 1st of this year, the CISA, or the United States Cybersecurity and Infrastructure Security Agency, added this exploit to its catalog of known exploited vulnerabilities. In other words, it's been verified that this vulnerability had been exploited in the wild. And this is why having multi-factor authentication or two-factor authentication is so important, because according to GitLab's own statement, users, quote, users who have two-factor authentication enabled are vulnerable to password reset, but not account takeover, as their second authentication factor is required to log in. And that, at the crux, is why multi-factor authentication is so important. Because even if your password gets compromised, whether that's due to your password's just bad, there's a vulnerability like this that allows an attacker to reset your password gets leaked through some kind of data breach, whatever the case may be, in the event you do lose that security of you being the only one that knows your password, if you have that multi-factor authentication set up, there's that additional check to ensure that you are actually the one logging into your account. Now, of course, there are ways to get around this. We've talked about SMS is not exactly the best way to do multi-factor authentication because the messages are unencrypted. Phone numbers can be spoofed. I mean, there's ways to get around it. So ideally, you don't want to be doing SMS. But again, it's better than nothing because at least there's the chance, a stronger likelihood, just adding another layer that an attacker would have to get around in order to gain access to your account. So this is why multi-factor authentication is so important to have enabled on your accounts. Now, when it comes to multi-factor authentication, it's generally referred to as two-factor authentication, but in reality, there's multiple factors that you can actually have for your authentication, hence the name multi-factor. And generally, it is in three different categories. It's something you know, something you have, and something you are. So the something you know is your password. The something you have is something like a hardware device, like if you have a YubiKey, that basically kind of authenticates you that way. If you have something like an authenticator app on your phone to generate, the two-factor codes, whether that's Okta, Duo, Microsoft Authenticator, Google Authenticator, or something like that. Or if you have some like private public key pair set up, so when you're authenticating, you can, send some signed certificate with your private key that can verify that you are indeed the one that sent it. And then, of course, the something you are, which is things like biometrics. So you can think of things like on iOS, you have Face ID. On Windows, you have the Windows Hello feature, which could either be a facial scan or like a fingerprint. So there's different ways that you can do biometrics, but biometrics is the third level, which is of the multi-factor authentication. So yeah, I'll have a link to the Hacker News article on the subject. But yeah, that is why multi-factor authentication is so important. And if you don't have it currently enabled on all of your accounts, you definitely should. So that is your cybersecurity tip for the week. And with that, let's roll right on into what nerdy stuff have I been up to this week. So I did some, I'm going to call it hacking. I don't know if that is the proper definition of what I was doing, but I'm going to call it hacking because it sounds cool. So what I did was I have a cluster of mini PCs that I had long intended to create a Kubernetes cluster with, which that project kind of never got off the ground for a couple reasons. One of them being I never really knew what to put on the Kubernetes cluster, so the PCs, for the most part, have been just sitting unplugged off to the side of my server rack, just kind of chilling there. The other issue of why I haven't really used them much is my server rack space is quite limited. I only have well, I guess depending on who you are, this might either be a lot or a little, but I only have 15 U of space, and currently it's basically all occupied at the moment. So trying to mount the cluster in the rack is kind of tricky, especially since I'd have to get some kind of like rack shelf, since of course these mini PCs are not rack mounted like some of the enterprise servers I have. But anyway, we're getting a little bit off topic here. So getting back on topic, the base operating system that I threw on these mini PCs was Red Hat Enterprise Linux 9. And if you listened to the episode, or maybe episodes I did on the free money glitch, as I called it, with essentially getting unlimited installs of Red Hat Enterprise Linux for free, that's sort of how I went about doing it. So in a nutshell, basically what I did was I created a Red Hat developer account, which is totally free. And with the Red Hat developer account, you get up to, I think it's 15, or at least that's what it was, 15 installs of Red Hat Enterprise Linux, basically for testing purposes, so you can, test your builds and all that good stuff. But as a side effect to that, what I did was I first installed it into a base virtual machine in Proxmox. So I just created a virtual machine, installed Red Hat, authenticated it through my developer account, all that good stuff. And then whenever I wanted to create a new virtual machine based off Red Hat, I would just clone that virtual machine and be up and running. And to my surprise, when I would do that and I checked my Red Hat developer dashboard, I guess you could say, of like all the listed devices tied to the account, no new devices ever got added when I cloned the virtual machine. So that was interesting, hence the kind of infinite money glitch. But if you're interested in that, I did a whole episode on it. You can find it. Now, the reason I bring that up is the way I installed Red Hat on these mini PCs was essentially doing I forget the exact tool I used, but it was essentially a hard drive or an SSD cloner, like a drive cloner. I forget the exact I don't remember. But I basically used a tool to basically over the network clone the virtual machine's disk onto these mini PCs in order to get Red Hat up and running. So anyway, basically what happened, and the reason why I'm bringing all this up, is the mini PCs essentially got bricked. So, and the reason I say they got bricked is because when I went to try and update them this past week, when I turned them on for the first time in I don't know how long, they would not update. I couldn't update them, and they ran into various errors, mainly from the subscription manager and some various certificate errors. So my first attempt to fix this issue led me down the road of manually mounting the Red Hat ISO image and pointing the package manager for Red Hat to the ISO image to update the system that way. Since that is one thing that you can do with Red Hat that's kind of cool. You could probably do it with other distros too, but you can point the package manager to point directly to like an ISO image. So even if you don't register the system with Red Hat, in theory, as long as you can get access to the ISO images, which technically you're only allowed to get those images if you have a Red Hat account. But I'm sure if you were determined enough, and you could probably find ISOs out on the high seas, but since I have a developer account, I, of course, got it the legal way. But anyway, that's kind of besides the point. The point is, you can install packages for Red Hat through the installation media. But that actually didn't end up fixing my problem, so because part of the thing that it didn't work also was I also discovered that I had no way to mount network file shares on these mini PCs, so I had to manually download the ISO image onto each one of these computers from my NAS. Now, that does sound horrible, but because thanks to my NAS having a 10 gig connection, each of the mini PCs was able to fully saturate their 1 gig connection, and my NAS didn't even break a sweat. So I have to say it was pretty glorious to see 4 simultaneous connections to my NAS, all at the maximum gigabit speed. It was quite fantastic. So anyway, getting back on topic here. So while it didn't work using the ISO image, what I was able to do was, because I saw it was a certificate-based thing, what I decided to do was go into my base image that I essentially clone all of my virtual machines off of, because that was still working and able to get updates and everything. So because I saw it was a certificate issue, I decided to copy all the various certificates, signatures, and all that good stuff from that image and upload it to the various mini PCs and put it in the proper locations. And after I did that, I ran the update and it updated without issue. So I suppose, assuming you could get because you need root access in order to copy all of the files. So assuming you could get root access to a Red Hat system, in theory, you could steal the certifications and signatures from that system that it uses to contact the Red Hat servers to essentially authenticate that it's like a legit and has a subscription and all that good stuff. So in theory, you could copy all of those, put it onto your own Red Hat system, and get free updates. I guess that's kind of what we discovered here, which, in all honesty, that kind of tracks with why cloning the virtual machine, 1, still is able to get updates from Red Hat, and 2, doesn't show up as another device inside, the Red Hat dashboard. Because if you're cloning all of these certificates and private keys and all that good stuff, from the Red Hat server perspective, it's the same exact key and same exact certificates and all that good stuff as this actual device that is authenticated. So as far as those servers are concerned, it's the same device, which makes sense because in theory, that's the only way that it would have the same keys and whatnot, because my assumption is when you register a new device or server with your Red Hat developer account, I would assume that, you're of course generating new certificates and new keys like you should be doing, and then reaching out with those keys and, authenticating with the Red Hat servers that way. So by using the same keys, it's basically like if you have, say, a SSH key that you use to authenticate with your GitHub account, say when you push code changes. So you can have the same GitHub, the same SSH key on multiple systems, and all push code to the same GitHub account, and it's going to be none the wiser, right? Because it's your private key for your account. So in this case, it's the same private key for that system, just on multiple systems. So that's, again, kind of why it makes sense where if you clone or copy, the entire virtual machine, you're also copying all those valid certificates and signatures for all the various authentication stuff that goes on. So I guess this is kind of another build upon of the infinite money glitch or free money glitch or whatever you want to call it for Red Hat, where you can essentially get free access to Red Hat without actually having to pay for it. Now, of course, if you are actually a business or anything like that, you obviously should not be doing this, because I think it's safe. I haven't, gone through all of the legalese, but I think it's safe to say that if you're using it in a commercial capacity, that's at the very least frowned upon. But at the same time, at least in my use case, it's not like I have more than 15. I think 15's the limit. I definitely don't have more than 15 Red Hat machines running anyway, so I'm definitely well within my limit. But even still, in theory, you could create multiple developer accounts and link them all. And like I said, if you want to really get into it, I did an entire episode kind of covering that. But anyway, that's kind of what I wanted to touch on, kind of hacking Red Hat Linux to get otherwise bricked machines back up and running. Now, another thing that I did this week was I talked a few episodes ago about, I guess a couple times on a few different episodes, getting a large language model spun up in my home lab running on my R620 with the GPU that it has in there. And in order to run the large language model and the stable diffusion in there, I first have to manually disable the fan control that I have running on the R620 and enable the fan control for the GPU, because the Tesla P4 GPU that I have installed there does not have a fan. So the only way for that GPU to stay cool is by the airflow from the server. And because it's technically not an OEM Dell card, it doesn't necessarily register with the Dell BIOS and firmware its temperatures accordingly, so the fan control doesn't account for it. So I basically had to create my own fan control script for the GPU that essentially queries the NVIDIA SMI tool to get the temperature and then scaled the fan curve accordingly. So quite honestly, I got kind of tired of having to do that process all manually, because having to log into two different servers, disabling the fan control on one, enabling it on the other, and then going into another terminal window, because currently the fan control script was literally just a script. It wouldn't run in the background at all without me having to do additional steps to find the process ID and then killing it afterwards. Long story short, there was a lot of overhead, and I got kind of tired of it. So to remedy this, those who have listened to the podcast for a while, or if you just read the title of the episode, probably know where this is going, because longtime listeners of the podcast definitely know that I am a huge fan of Ansible. And I decided to create an Ansible playbook to essentially automate this entire process for me. And my goodness, is it fantastic. It makes my life so much easier, and it removes a lot of the friction that I had to using the various artificial intelligence toys, I guess you could call it, that I have in my home lab. Because the biggest piece of friction was, okay, I want to use this, but I got to log into the server, disable the fan control, then log into the other server, enable that fan control, and then actually spin up the AI thing that I want to play around with it, and then I have to go back and disable the fan control and then go re-enable the other one, and it was just a pain. Now I can just I can run a single command that will enable it or disable it for me, and all I have to do is specify the associated tag, so either start or stop, to start and stop the GPU fan control respectively. So it makes it so much nicer, and I actually used it this week. As we'll discuss a little later in the episode, I asked it some game dev questions, but it made it so easy because I was like, you know what? I have this new Ansible playbook now. I will run it to switch the fan control over to the GPU and start my large language model, and we were off to the races. So it was quite fantastic. If you've never played around with Ansible before, I definitely recommend it. Especially if you have a home lab and you have multiple systems, virtual machines, servers deployed, it makes your life a heck of a lot easier. So I cannot recommend it enough because it is a fantastic tool. Now, getting into some of the game development stuff I was working on. So I actually made a decent amount of progress this week. So first up, I got the HP bars in the... So I've been working on, of course, the Pokemon summary screen the past few weeks, and I finally got the HP bars and the remaining HP and the total HP fully implemented in the party screen, and I completely rewrote the function that handles the displaying the HP, so it actually gets formatted and aligned properly regardless of the number of digits it has. Since, well, I kind of sort of had that implemented, it was a little finicky, and especially if you had like two HP values that were right next to each other, like specifically in the party screen, where one of them was 2 digits and one of them was, say, 3, you could definitely notice a difference in the formatting, and that, of course, did not look good, at least in my opinion. So I decided to refactor that, rewrite it, and now it actually looks like it's supposed to. And in the spirit of rewriting and refactoring, I did do some more of that and went through some of my constant variables that I had and changed them to constant expressions. And if you're unfamiliar with the constant expression keyword or constant expressor, it's kind of truncated. If you're unfamiliar with that with C++, essentially what that does is it tells the compiler that code can essentially be computed at compile time. So for instance, if you create a constant expression function, depending on the context that function is used, the compiler will actually go through the steps of using that function to pre-calculate the value that it would return and just essentially hard code the return value inside your program. So when you actually go to execute the code at runtime, you don't actually have to go through that function at all. The return value is already hard-coded in there, so you can just keep going. So the benefit here is for certain values will always be constant or can be pre-computed ahead of time. You don't have to worry about doing that extra computation during the runtime of your program, so you can get some, depending on what you're doing, you can get some fairly significant speed increases by computing that at compile time. Now, of course, depending on what your function is doing, it will make your compile times longer. But I would argue I would take a longer compile time for a much more optimized, much faster running executable file any day of the week. So that's why I kind of started switching over to some of those. And I also got the functionality for switching the order of the Pokemon in your party completely working. So I was quite hyped to see that. And I guess the other thing that I'll touch on, which kind of leads into the final topic that I wanted to cover in the episode, but first, I kind of updated my makefile once again to reduce the file size of some of the release builds. So I cut the binary size essentially in half for both macOS and Linux. Now, Windows is essentially unchanged, for the main reason being that Windows, currently how I'm building it, is built against a dynamic library, whereas on Linux and macOS, it's being built against a static library. I talked about the reasons for why I did that a few episodes ago, but the main reason is the RHEL library that I'm using, it doesn't have a native build script, or it doesn't have a native build for the Windows development tool I'm using, which is MSys2. It has compatibility for MingGW, but it doesn't have compatibility for WinSys or MSys2. The benefit, though, is you can install MingGW through MSys2. So essentially what I'm doing is creating a dynamic library with MingGW and then compiling the executable I'm building with MSys2 against that dynamic linked library, or the DLL, and essentially getting the functionality to work that way. So kind of going through a little hoops, but that's essentially in a nutshell what I'm doing. So, but because that's building against a dynamically linked library, you don't have the code for the library essentially embedded in your own executable like you would for building a static library. So essentially what I managed to do here was the way I reduced the binary size was essentially removing all of the quote-unquote dead code, or code that gets put into the binary that doesn't actually get used by anything. So I added a few additional compiler flags to essentially be able to enable this feature. So I essentially took the executable from about 1.4 megabytes on both macOS and Linux down to around 700 kilobytes on macOS and around 800 on Linux. So essentially cutting the executable size in half, which was quite cool to see. Now, of course, that is quite deceptive for the actual game itself, because it's not like the game is anywhere close to being done. So, of course, this file size will get larger. But it is cool to see that large of a reduction in file size just by doing adding some additional compiler flags and whatnot. And that leads me into the final topic for the episode that I wanted to touch on, which is embedding assets inside your executables versus accessing them from disk. So currently how I have it set up is it accesses the files from disk. So essentially what that means is when my executable runs and I want to, say, load a sprite or load the font or whatever asset I want to load, I have to reach out to the file system, to the operating system, and say, hey, I want this file from disk, and I have to give it, the relative path to wherever that asset has to be, and then it gets loaded in and then displayed. And this works great. But I recently discovered that RHEL has built-in functionality to export data and assets as header files. So essentially, you could take an image file, like say you take a PNG that you're using as one of your assets, you can load it into RHEL as an image struct, and then you can export that image struct as a header file, which you could then re-include into your project and essentially embed that image asset into your binary, so you don't have to do any kind of file access or anything like that. So it has native support for images, fonts, and certain types of audio, and then just a general data that you can export as well. So the benefits, so I was this past week, trying to identify kind of the pros and cons of each, because the obvious pro here is that you can basically embed everything inside the binary, and you would no longer need any kind of resources folder or anything like that, and you wouldn't need to load any assets from disk, and all you would have to do is just essentially call and go to the memory address inside your binary where that image is, and you can load it and potentially significantly speed up the performance of your program, because you don't have to go through all those additional steps of, actually reaching out to disk, making the system call, and all that good stuff. And actually, the embedding everything in the binary is actually what the original Game Boy games did, specifically the Pokemon games, but I'm pretty sure all Game Boy games in general, because if you have the means to dump the data on your Game Boy cartridges, what you'll end up getting is a single file. It's the ROM file or the read-only memory file for the entire game, and it's just one file. And if you look at the source code for for example, Pokemon Emerald, is someone created a decompilation of the ROM and essentially reverse engineered it, I believe, is kind of what happened. But the images essentially do this exact same thing. They get converted to header files, and then those header files are included inside the binary itself. Now, I did some initial experimentation with this, and it works, but unsurprisingly, it massively increases the size of your binary. Of course, it depends on what assets you're using and, how big they are, file size wise. But also, in addition to making the binary grow quite substantially, the header files that it generates are also quite chunky as well. And what I found is in some cases, in a fair number of cases, they ended up being significantly on orders of magnitude larger than the actual file itself. So for instance, like image files, it would be like in the megabytes of size where the actual image file was only, in the kilobytes. Now, this kind of makes sense in a way because how images work is they're compressed, right? We did an episode a while back on different types of compression, but they are a lossy compression essentially, where they're able to be compressed in a way where they don't have to retain every single bit of information, but they retain enough information so you're able to recreate a pretty good representation of what the original was. So it's not a lossless compression where you're able to fully reconstruct the image when you decompress it. But because of the compression that you're able to do, you're able to, get a smaller size. So in that sense, it kind of makes sense that the raw data that you're extracting would, in theory, be larger. But still, it was quite... I just wasn't expecting how massive some of these header files would be, like I said, on the order of megabytes. But anyway, this kind of got me thinking, trying to identify the pros and cons of what's better with including everything in the binary or, referencing and just having like a separate resources folder. Because if you include everything in the binary, like I mentioned, you totally eliminate the need to access disk, which, as we've discussed in this episode and in previous episodes, is quite slow, especially when compared to accessing memory. Since we did an episode not too long ago where we talked about, the cache performance, right? And how if you go out to, say, main memory, even from your CPU cache, you accrue a decent amount of overhead. And even further, if you have to go all the way out to disk, like you're using swap memory, you even further degrade your performance because of the latency it takes to, pull that in. So add on top of that the fact that you have to make a system call in order to access the file system. It just would further slow things down. So the fact that if you embed everything in the binary, there's no disk access and there's no need to make any system calls could significantly speed up the load times when loading in various assets. So, but honestly, I was quite torn because I want to, of course, make this as, performant as I can, but at the same time, I don't want to be, like a modern game where, the final executable ends up being like hundreds of gigabytes, right? Now, of course, I don't actually foresee this game ever getting close to that magnitude, mainly because the assets I would be using aren't like, these massive renderings of things and 3D models and all this stuff that modern games have. Of course, it's all like just pictures and 2D sprites and all this stuff. But still, regardless, of course, I want to try to make this as small as possible and as optimized as possible. So, of course, embedding everything into the binary would significantly increase the size of the binary, but at the same time, it increases the overall performance. So, which is better? So I had some ideas in my head, some pros and cons, but I wanted, I guess you could say, a second opinion. So, like I mentioned earlier when I was talking about the Ansible playbook I created, I decided to use that and spin up my LLM and tried to ask it, which is better, give me the pros and cons, and that kind of thing. So some of this is going to sound quite familiar, but I kind of wanted to touch on what it kind of recommended and just kind of have a conversation with you, the listener, about what, the pros and cons of actually embedding your assets into your binary versus having them in their separate resources folder, because this is something that I'm currently trying to work through what I want to do. And hopefully if you're in a similar boat as me, maybe this can also help you decide what you want to do. So first, when it comes to actually embedding the images into your binary, so essentially converting things like images to .h or header files, files. So as we already mentioned here, the LLM suggested faster loading times. Of course, we had kind of already established this. Since the images are embedded directly into the binary, there's no need to load them separately when the game starts up, or level transitions or scene transitions when you have to, loaded new assets. So because of those faster loading times, could improve the user experience. Again, we kind of already touched that. Portability is the next point it gave. So it says when distributing your game, you don't have to worry about including separate image files since they're all part of the binary, which this also makes sense. It definitely reduces the complexity and portability, because as part of my make file and the Ansible playbooks that I created to create release builds, part of that release build process is copying all of the resources, like all the various resource files, like the fonts, the images, all that good stuff, and copying that entire directory and putting it in the proper location to actually package it up in order for it to be shipped. So by just embedding all that stuff in the binary, you literally just compile the program and you're good to go. You don't have to worry about any additional steps like that. And another reason why I kind of like this idea of it being way more portable is one thing that I constantly run into is, so I've mentioned this before, that I do the majority of my development for this video game on Mac OS. And specifically, I've been doing it mostly in Xcode. And the nice thing about that is it, can build everything for me, and I kind of don't even have to worry about the make file. The only problem is, it's partly due to my own fault, is I don't have the Xcode build process fully set up to the same caliber as the make file is. And what I mean by that is the program relies on a couple dependencies to run, right? It requires the RHEL library, which currently the Xcode project doesn't build. So if it doesn't exist, it'll just fail to build the program because it can't find the RHEL library. Now, it is on my to-do list in order to try to see if I can't get that implemented, but it's not, in all honesty, it's not all that high on the priority list. But the second thing is the assets. So I could probably, again, it could be done through various tweaking, but the thing is, when the Xcode project builds, it just builds the binary. So if I had recently cleaned the build directory or the bin directory, it would essentially wipe out all the resource files. So when I would go to run the executable, there would essentially be a bunch of, shall we say, undefined behavior, because, well, not necessarily undefined behavior, but none of the image assets or fonts would actually load, which of course is not ideal. So then I'd have to kind of cancel, the run and copy over the resource folder and all that good stuff. So just extra steps. So the idea of just having everything pre-built into the binary just makes everything kind of so much easier, which kind of goes into its next point here, which is a simplified development process. So essentially by embedding everything inside the binary, you reduce the dependency on any kind of external files, making the development process more streamlined, which, makes sense because you literally just build the binary, and in the process of building the binary, you are already packaging in all the various assets that you need in order for them to be displayed correctly and work efficiently. And it also says, touches on for certain platforms such as embedded systems or mobile devices with limited file system access, embedding images directly in the binary might be the only viable option for distribution. Now, another thing that I kind of wanted to touch on with this too is kind of on the embedded systems front, but also depending on what system you have, if you embed everything in the binary, another benefit that has is because you're not having to go out to disk, if for whatever reason, say if you're using a Raspberry Pi and you're booting off an SD card, if all the assets are on that, micro SD card, a micro SD card isn't going to be nearly as fast as, say, an SSD, right? So again, kind of increasing the loading time. So you can essentially guarantee a more constant performance by embedding everything in the binary. You don't have to necessarily worry about those load times. Another thing it touches on, which I, as the cybersecurity enthusiast I am, didn't even necessarily think about this as the initial back and forth that I was having with myself, is security. And it says, since images are embedded in the binary, they're less susceptible to being tampered with or replaced externally without modifying the game files. This can be advantageous for games that require high levels of security and anti-piracy measures. Now, I don't necessarily have to worry too much about the high levels of security and anti-piracy measures, because as I've touched on before, this, when I actually, if it ever comes to fruition and actually, get this game done, the goal of it is to make it completely free and open source for essentially anyone to be able to view. I plan to put it on GitHub when I kind of get it into a more finished state, shall we say. So, of course, anti-piracy measures not really going to be a factor. High levels of security, I mean, it's not like this is proprietary code, so, I mean, it's going to be all open source anyway, so there really isn't a whole lot there. And again, the last point here is constant performance, which we've also kind of already touched on. But yeah, going back to the security thing, that other factor about making it less susceptible to being tampered with, which makes sense, right? Like the one thing you don't necessarily want is, some file in the resources folder to be renamed or mislabeled or something like that, or you change the name of it but forget to change it in your code, and then when you run the program, the asset doesn't load, and that. But if it's all built directly into the binary, it kind of reduces that risk. Now, moving into some of the cons, one thing we already touched on here was the larger binary size. Of course, it makes sense if you're embedding all of this data. You're essentially hard coding all the data for your various assets within the binary. So it's, of course, going to make the binary size much larger. This next one, it says less flexible. So this one, I see where it's going. It says if you need to make a change to an image, after development, you must recompile the entire project, which makes it less flexible. Which, quite honestly, I have experienced this, because when I'm kind of developing my various tile sets for the various scenes, or if you will, I'm, of course, tweaking these quite frequently in order to, give them the way I want. And having to constantly recompile everything every single time just for a minor tweak to an image would be a royal pain. So just having the ability to, just reach out directly to the disk to access the image allows you to change the image without necessarily having to recompile the entire program. And this next one doesn't apply to me because, as we already touched on, RHEL includes the functionality to convert assets to header files, but it is something to make note of, which is a more complex development tools are required. So it's specifically referring to game engines here. So some game engines or development tools might not support this functionality, that being embedding assets directly into your binary. And you'll need to invest in specific development tools that can handle image embedding for your target platform. Again, for my use case, this doesn't apply to me because RHEL already has that functionality built into it, so I can take advantage of it. And the next one, reduced ability to optimize images. So kind of one thing we already touched on, the header files can be quite chunky, and because you can compress images, you can kind of play around with the various compression ratios and compression settings for your images to reduce the size of those images or other assets. So by, doing various optimization strategies to your compression, you could, in theory, create much smaller assets and resources, which could overall make the final delivery of your, game or whatever executable you're making smaller by, using some of those optimized compression strategies. The next one here it mentions is limited dynamic image support. So if you embed all of the images directly into your binary, you can't necessarily make changes or swap out images for like testing purposes, which again, for me currently, kind of still in the main flow of the development process, is something that is quite nice to do. If I don't like how one image is working, what I could do is I could rename it to something else, copy in a new version, rename it to the same name, and I don't have to worry about recompiling the entire program. So that is definitely something to take into account. But again, if you're at the point where everything's kind of finalized and you're just building the final executable and you're not making tweaks to your actual assets, I don't know if that's necessarily as big of a con. But definitely during the development process, that could be quite an annoyance. So now moving into loading images from the disk and not embedding them inside the binary. So of course, the most obvious pro here is the smaller binary size, which we've touched on, because you're not embedding the raw data into the binary. It of course results in a smaller binary size. And kind of everything that was a con for the embedding images in your binary is now a pro. And vice versa, everything that was a con, or everything that was a pro for embedding is now a con here. So more flexible, it touches on. So, loading images from the disk allow you to swap out images for different ones to test various images for development or other assets in general. And it can be helpful for debugging without having to recompile everything, which, as I've touched on, is something that is quite nice and something I have personally done with this project. Then it talks about easier development process, which again, we kind of already touched on this as a con before, but again, this doesn't really apply because this is specifically talking about you might not have the means in order to embed images, but of course that doesn't really apply to me. The dynamic image support, we kind of already touched on that, on why it's a con and why it's a pro here. And yeah, the compression optimization, you can, of course, optimize compression. We kind of already touched on that. Getting into the cons, it's, like I said, pretty much the reverse for the embedding. So slower load times because you have to physically make the system calls to reach out to the operating system, pull the files from disk, load them into memory, load them onto the GPU. Whereas if you embed everything, you can just pull it out of the program because it's already there. You don't have to worry about making any system calls or disk access or anything like that. File dependency, again, is another one. You have to worry making sure all your pathing is correct. There's a potential chance that, a file could be corrupted or something, in which case, like if you're, say, when you're doing the final build process, if you say put everything where it's supposed to be and somehow maybe when you're zipping everything up or somewhere along the stage something doesn't get copied quite right, you could potentially have some corruption there, which then when you try to load that corrupted asset, you run into some issues. So there is some potential issues you could run into with depending on external files for your program. And then this doesn't really apply to my use case, but I thought it was, valuable to bring up, which is if you are loading images, say, from the internet, and you need like an internet connection in order to load some of your assets, depending on the connection and your connection speed, that could potentially have some pretty degraded performance if you don't have a good connection speed or your network connectivity where you currently are isn't that great. So that could potentially be another downside to not embedding your images directly into the binary. So we've kind of touched on, a lot of different things. Of course, it's what's a pro for one is a con for the other and vice versa. So what am I going to do? What is my current approach? So for the moment, I'm thinking I'm going to do both and just kind of see how it goes. Now, if you're wondering how I'm going to do both, the good old if-def check. So what is the if-def check? So if you're not familiar with what the if-def check is, it's essentially a preprocessor macro that tells the compiler whether or not to include the code. So in instances like where you're creating header files, there's the classic if-def, name of the header file, define name of the header file, right? So essentially what that's saying is if this file isn't already included during in the link process, don't include it if it's already included, and if it's not already included, then include it. So essentially what I can do here is I can define essentially a variable at compile time if I want to embed images or if I don't want to embed images. And then inside the code itself, I can basically just check to see if that variable is defined or not. And if it is, then do the process to embed the image into the binary. And if it's not defined, then don't worry about embedding it and just skip that process and don't even include that code in the final version. So I plan to test both variants, both with the embedded images and assets in the binary and that without, and then kind of just see, what performance is like, what file size is like, and just kind of do a comparison before I finally settle on what I want to do. And one thing I probably won't do is include the header files for the assets because, as I mentioned, they are quite chunky. But in order to have the header files, I need some way to convert the assets to header files. So naturally, what I did was I started working on a compiler, as you do. So I'm calling it an asset compiler. Now, while that might sound impressive because it has compiler in the name, don't let that fool you because it's basically a glorified directory parser. But even less impressive is I'm not even the one writing the directory parser code. So while it does kind of sound impressive, I'm about to make myself sound like I did absolutely no work. So basically what it does is it parses the directory that you give it and checks the file type by looking at the extension and then determining which associated RHEL function it should send it to in order to generate the requisite header file. So kind of as I mentioned, I'm not doing any of the work here because I'm just wrapping the RHEL functions to convert assets to header files. And in addition to that, RHEL also has functionality to get all files in a directory, as well as get the extension of files and get the timestamps of files. So I'm literally just writing a program that automates the process of converting these assets to header files by just calling various RHEL functions that already exist. So I'm essentially kind of taking something that already exists and I'm not basically writing any of this code myself. Now, that's not to say I haven't done it before, since I have written my own directory parser, file extension, pooler, and all that good stuff, getting timestamps. It's not that these functions are that difficult to write. It's more of, okay, I'm already using this library, that being RHEL, to convert the various assets to code. So because I'm already using the library and linking it, I might as well use the other functions that it's giving me to make my life even easier and speed up the process of creating this asset compiler. So yeah, I'm not really doing anything here. Now, what I will say is I am multi-threading it, so I guess that's something, right? Right? Something that I actually did myself. So I am essentially multi-threading it so in the event that, you're trying to compile, your entire project's worth of assets, which could be a significant number, being able to multi-thread that and do them concurrently is definitely a nice plus. But again, at the end of the day, it's still the RHEL library that's kind of doing all of the legwork. But I would be lying to you if I said that asset compiler doesn't sound way cooler than something like RHEL asset to code wrapper or something like that. Because in my opinion, asset compiler sounds pretty darn dope. So that is my current plan. The plan is to kind of try both ways. I'm still putting the finishing touches on the ASCII compiler. It works currently right now. It's able to take images. Currently, it only works with images. I haven't gotten fonts and sound and other things implemented yet, but it's at least able to take images. But in fairness, I'm not even using audio at this point in the game. There is, I think one font, so I will eventually have to include that. But currently, of course, just starting small with some tests, it is able to take an entire directory, parse it, convert all the images to header files. There is still some tweaks that I need to make and get it a little more polished. So there is still a little bit more work to do. But once I get that, my plan is to convert, my various assets to header files and then start doing those if-def checks to put them into the code and then start experimenting and kind of see what I like more. So yeah, so that was a whirlwind tour. So hopefully if you are currently, even if you're not doing any kind of game dev, but you have to deal with, embedding or using assets like text, like fonts or images or audio or something like that, and you're kind of wondering what the best way to have that integrated into your program is, hopefully this kind of gave you some insights into how you might go about doing that. But before we leave for today, let's get back to our trivia question for the week. So we touched on it in the middle of the episode, Ansible. So Ansible, which is an IT automation tool, is primarily written in what programming language? If you said Python, congratulations, you are correct. You got this week's trivia question correct, which I guess if you said C, you would kind of also be right because Python is written in C. But then again, if you said assembly language, you would again also be technically correct because everything has to get converted to assembly at some point. But yeah, the actual language it's written in is Python. If you go to the GitHub page, it is vast majority Python. So if you enjoyed this episode, I ask that you leave it a rating, review, subscribe if you haven't done so already, and be sure to share this episode around with any friends or family members that you might think would be interested in it. And if you have any questions or comments or topics for future episodes or have anything you want to ask about this episode, you can of course leave a comment down below if you're on YouTube, or you can shoot me an email at contact@darkassassins.inc.com. There is a link for that down in the show notes below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.